Okay. So last time I went over these basics, I said MATLAB's an interpreted language. Okay. An interpreted language just means there's no compiler. You're not writing it and compiling it. It's just going to run. All right. Downside of that is it always means that mistakes can easily happen. If you leave MATLAB open on your desktop for 2 weeks, variables you defined 2 weeks ago are still there. Right. So there's a potential issue that you run into. You write scripts. A lot of you probably heard that terminology before if you've never actually used it, but it's scripts. Basically just a series of commands that you feed in and it just executes those commands. When you use it, again, what I was saying the other day, it opens up with a command window. That command window usually has other windows inside of it. The command window is a tiny little thing. All right. I usually like to keep it like this where it's undocked. There's 2 types of scripts. There's live scripts and just scripts. A lot of people use live scripts. I think this is some attempt by MathWorks, the manufacturer, to get more Python-like. I don't recommend using that. I've seen people run into issues with it. It's probably not hard to use, but I'm not all that familiar with it. So I recommend just using the regular old scripts. Okay. So you'll see me, I'll have my editor window here where I'm just running code over here that I write. I never really run code here directly. I usually write it, and when I'm going to run it, I highlight it and evaluate the selection, right? Is the way that I'll typically do that. Okay. All right. Or you can copy and paste it into the command window or whatever, but you usually just evaluate selection is the way that I'll do that. Okay. So like I was saying the other day, MATLAB versus C, MATLAB doesn't have pointers or any of the memory management stuff that you got to worry about in C. All right, so it's much more straightforward in that sense to me. Yeah.
So the way the homework was formatted, I guess we had like the little MATLAB browser. Is this going to be like how it usually is, or we're going to have to do the actual MATLAB?
Yeah, that's a good question. So I mentioned that briefly, but yeah, now that you're in the homework, you're seeing this. So all of the homework will be submitted via that browser window. All right, all of it throughout the semester, because it's an easy way for me to be able to take your inputs. Right. I recommend downloading MATLAB. You will need, when you get to the 2 projects, the 2 projects will need you to run a standalone MATLAB. It's not a browser thing at all. I recommend doing that because it lets you kind of write your code and play around with your code before you stick it in the browser window, and getting used to it's probably good. The plotting and some of the stuff's weird in the browser window, so playing around with it here is probably useful. So yeah, you're gonna need to download it at some point, so you might as well. All right. So last time I said MATLAB, that what it stands for, matrix laboratory is the term, right? So it's meant to deal with matrices, and that is a very standard and normal thing to do nowadays, is to think of everything in a matrix linear algebra format. So you guys will say arrays a lot because you're used to thinking in C terms, but really in MATLAB terms, we call them vectors. All right. So they are either a single column or a single row of entries. Okay. So when I look at this here, right, I define 2 vectors here, T1 and T2. T1 is a row vector, right? So what I wrote here is it's always square brackets, and it's numbers 1, 2, and 3, right? 1, 2, and 3 here, that if I write them without any kind of semicolon separating them, they go on one row. If I write like I did here, 1, semicolon 2, semicolon 3, that they will be column vectors. Okay. Now, what do you think I did here? Yeah. So if I talked about this, this is a matrix now, right? How many rows and how many columns is this A that I wrote here? 3 columns, 2 rows. And so typically, I think you would call that a 2 by 3 matrix, right? So in linear algebra terms, you'd call that a 2 by 3 matrix. Normally you say m rows by n columns. All right. So one thing we're gonna talk about a little bit here is it's useful sometimes if you're not sure, like you may just have a vector that you're dealing with and it's a big vector, probably has more than 3 entries, probably has thousands of entries. And you want to check the size of it. All right. If you want to know what the size of it is, one useful command that I often use, there's 2 useful commands. I talk about them later here in the notes, but I'll bring them up. So that one of them is size and the other one is length. So if I do size of, so t is one of the variables I have defined right now. So t 101. Now, if I want to know how that command works, like what did I just see? I can type help size, or I can go to Google and just put that in there. So size will tell me what this guy is. So it tells me the output is an m by n matrix. Tells me the number of rows and columns in the matrix. All right. So the command that I ran here was specifically, I did size of t, and it said 101. So what's that tell me about that t vector? 1 row, 101 columns, okay, is what's there. So that's useful to me when I want to try to do multiplications, which we're going to do some multiplications or operations, right? So we're going to do some of those operations here in a little bit. All right, so I'll talk about some of those useful commands too. All right, so we talked about this briefly the other day. So there's my row vector, there's my column vector. If I plug those vectors into a function, so sine is a function that MATLAB has to find, what do you think I'm going to get out of x1 and x2? If t1 is a row vector, what's x1 going to be? Row vector. T2 is a column vector, x2 is going to be a column vector, right? They're going to come out with the same size that went in. All right, that should be pretty straightforward. Now, where we ended up the other day was I started talking about plotting, right? So I said, you guys have some plots of sine functions to do in problem 4 on homework 1. What that means in this context, so I wanted to plot this from negative t to t, which again, I shouldn't, it's going to look something like that ish is what it should look like. All right, at least from where one period starts to where it ends. Okay, so this is what this function should look like with an amplitude. What would its amplitude be? 10. All right, so we go from 10 to minus 10. So this would be minus 10, and this would be 10. And if I put a number in for t, what would that number be for that function? So capital T, the period, what would that number be? 1/10, so 0.1 seconds. Okay. All right. So what I got to do in this case is when you're making a graph, or you're trying, basically when I'm making a graph, I'm trying to create a function, and I want that function to be representative of what it would really look like in the real world. So what I do is it's really 2 steps to do it, right? I got to create a time vector, and then I got to plug that time vector into the cosine function to make the vector that I'm trying to plot. Okay. So in this case, what I do is I tell this thing that I start at negative t, and then I increase. I use a colon to say, okay, start at negative t, increase in some increment value up to t. All right. So the other day I said, as an example here, if I just had some vector that was starting at 0, going up to 100, and I wanted it to increase in integer steps, I have 0, steps of 1 up to 100. All right. So the question would be, how do I make sure that if I'm trying to make a graph of a function that it actually looks right? Yeah. Yeah, and that was what I sort of suggested, right? Was that if I were to do this, I would say I start at negative t and do it, at least in steps of 100, but 1,000 is often what I end up sort of suggesting. Now we're going to talk about that. Defining time steps is really, what do you want to do? You want to make the time step small enough that you can see all the features of the waveform properly. So what that means is you got to use your head about what the features are going to look like. So that's something in the project that's going to drive you guys a little bit crazy at first, I think, when we get into the first project, because in that case, I give you real systems and you're going to have exponentials and sine waves, and you're going to have to use your brain for what you think the function should look like to decide the features. All right. So what I use is kind of a rule of thumb typically, which is to say that my feature here, my delta t, I often call this delta t because it's the time step. It's the distance between individual increments. I usually say that this should be a factor of 100 smaller than whatever the most important feature is. All right. That doesn't mean a whole lot to you at the moment. I'm gonna, for now, be telling you guys, use this time vector, right? Or use this time step. Okay. All right. The important thing, that I was kind of saying is really, if I give you something like this, 10 cosine 2 pi 10 t plus 45 degrees, that's an analog signal, right? As I write that, it's an analog signal, meaning t is what? T is what kind of number? Real number? It's a real number, right? T is a real number. So basically, what's a real number mean? So between 0 and 1, how many real numbers are there? Infinite, right? That's impossible to put into a computer. So we need to come up with reasonable time steps. That's getting us into closer to digital signals, but really what I said is it's getting to what I call discrete time signals. All right. So the word discrete basically means that there are specific locations at which I sample it. It's not sampled everywhere, right? That would be a continuous time signal. A discrete time signal is sampled at certain points. All right. So that's different than digital. The difference between digital and discrete time, a digital signal would be sampled in terms of its values along the y-axis, right? If I have a digital signal and it's 8 bits, how many different y-axis values can I have for an 8-bit signal? Well, with an 8-bit signal, I could have 2 to the 8, right? So I could have 256 values. We're not talking about that part of this, right? We're talking about the fact that I'm sampling it at certain points in time, certain points along the x-axis, okay? So what I said the other day is I said, well, here's a piece of code where what I did, so for that same function, that 10 cosine 2 pi 10 t plus 45 degrees, right? I took that and I said, well, make a t vector here that starts at negative t, increases in steps of t over 2, and stops at t. All right, so if my capital T vector, or my capital T period of this guy was 0.1, so if I look along the x-axis of this plot, this is negative t, this is negative t over 2, that's 0, that's t over 2, and that's t. What I did here was I made a plot where I basically put the values of this function at those points, right? So there's a value here, you can see that circle. There's a value here, 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 and here. That's not, if you ask yourself, does that look like this? It doesn't really look like it. No, those are values that are the term I keep saying is those are values that are sampled from that. That term sampling is a term that's commonly used in ECE type of problems where I'm thinking about having let's say an analog to digital converter that samples a signal at particular points in time. Okay. So if this 10 cosine 2 pi 10 t plus 45 degrees was a voltage that was being measured by an analog to digital converter, if I sampled it this slowly, in other words, I only plotted it at so many different points, it would look like a pretty crappy waveform. And I showed last time, here's the way that would look. Both of these graphs, the one on the left and the one on the right, are basically, this one is that t over 2 jump. This guy is that t over 1,000 jump. They're both the same function, but they look entirely different. All right. The job for you is always going to be to choose this time step so that it looks correct. Again, not so much of an issue for you now, but I really want to introduce this idea early on about how you think about these things as you are drawing what really amounts to approximations of the true waveform. You can't draw this true waveform. It'd be impossible. It would take infinite memory to do it. All right, so we got to sample it smartly. And we said what we do is when you draw graphs, you typically do a linear interpolation, meaning you draw lines between the points. And if you got enough points, those lines will be so small that you won't be able to tell the difference. Okay. That's what, when you run the plot command, that's what it does. So where I ended up last time is here's a piece of code that would work. All right, in this case, I'm drawing a plot from 0 to 2 times t. All right. And I'm saying, x goes, here's a function that I'm trying to plot. And I'm saying, here's a set of commands. Now it goes over these commands specifically in chapter 3 of the book, and I point you to where to look for that. When I do this plot t comma x, what that does is there's a different, I could write plot x. That would draw a sine wave as well. If I do plot t comma x, what it does is it uses the t values to label the x-axis, and it uses the x values to label the y-axis. So the graph that I would get if I ran this particular code, just run that real quick. So I can take that and I'll paste that into MATLAB here. Now, what should I do before I paste this into MATLAB? Clear all. Yeah, it always helps me just to make sure I'm not going to screw something up. So I paste it in and I get that. Okay. All right. So what would I see? What would it look like here on the, if I just said instead of t comma x, let's say I did plot x. What do you think I would see differently here? What's that? Well, yeah, so the y-axis values will still be labeled the same. So the y-axis values are labeled the same, but notice what happened down here. Right? What happened down here? The bigger numbers. What do you think it's writing down there on the x-axis? Well, let's take a look. Let's look at the size of x here. The size of x is 2001 points. Okay. So what do you think it's got down here? 2001 points. So it's labeled, basically, sometimes we call this the sample number, right? So it's saying, basically, I have samples that start at the number 1, the first entry of the vector, and end at the very end of it. Okay. So typically I don't tell you to look at stuff that way. Usually I say, you're plotting something in time. So if I do t comma x, what it does is it plots the values of x at the times in t. Now, if t and x are not the same size, what's going to happen? It's going to be an error, right? I have to plot 2 vectors that are the same size. The first one is the x-axis values. The second one is the y-axis values. And that may confuse some of you guys because I keep using x as the y variable, right? But as I said, we tend to use, right? We tend to say that our functions, x of t, our functions are usually of time. We're talking about ECE problems. We're talking about voltages, we're talking about currents, we're talking about those sorts of things that exist in the real world. All right, x is our usual input. All right, and I said y is our usual output. And we'll use that terminology a lot later. All right. Questions about that? All right. Pretty straightforward idea. One thing to point out, if you run this example later, right? I'm not going to run this one here, but notice what I did. I find 3 different time vectors and 3 different x vectors, and then I run these guys together. What do you think that's going to do? If I do t1, x1, t2, x2, t3, x3, what do you think that's going to do? Put all 3 of them on top of each other. All right, so I guess it's not, let's run it. All right, so there I can see, right, the difference here between these time vectors, right? So I had one that's t over 100, one that's t over 10, and one that's t over 2. So the yellow one here, which one is the yellow one? Yeah, the t over 2. If you look at the t over 10, that's the one that's the red, right? You can see this, the fact that he's not rounding out as much near the top, where basically there's a lot of action going on in the sine wave. Okay. So you just got to be smart about, what do I expect it to look like? Well, I know if I'm drawing a sine wave, I shouldn't see something that's kind of missing pieces like that. All right. So if I'm seeing it missing pieces, I know I got a problem. Yeah.
I vaguely remember there was some function to change the color for the blocks or something like that.
Yeah, you can pass other arguments here to plot to tell it to change the colors. Unless that's something I wouldn't probably tell you to do. The stuff that I tell you to do, like in the homework right now, is to do things like turn on the grid, look at Y label, look at X label. And I point you to the sections in the book that talk about that. If you wanted to change the colors, you can do stuff like adding in arguments here that tell them. I don't even remember. I think I put the color name right after the first pair if I wanted to change that. But I'd have to look that up before I even did it too. But if you go to specifically, if you Google like a command like plot, it'll have all kinds of examples. And those examples will have code, and they usually have a button that says, let me see, here's an example. So it says, try this example. If you click that button, it'll paste the code, and you can just drop it, or it'll copy it. You can just paste it right into MATLAB to try it out. Okay. All right. Now, this is an example of what I said. This one wouldn't be so bad here, but I said code's always right. Okay, and it is. If you ran this, right? So I had a t vector that's got 3 entries. I got an x vector that's a matrix. Nothing stopping me from writing this function right here where I say, okay, figure 1, plot t comma x. What's that going to do? Well, it's going to be an error, right? Now, this isn't a problem, but again, I've seen situations where people have, 200,000 columns and 200,000 rows, and they're sitting there for 30 minutes and their computer's just frozen. That's going to cause a problem eventually for you. All right, so that's like Control-Alt-Delete moment right there. Okay. All right, so that's what I'm saying. That's the kind of thing you want to check for. That's why one thing I point out a lot that's a really useful. All right. There's a number of useful commands. Where did I put it? Maybe I didn't. One really useful command is size. All right, I should include that before I post these notes. Is size and length. If I use the size command, and I've used it already here today, the size command will tell me the size of a vector. Often I try to use that before I do anything. Okay, any kind of manipulation or plotting, so I avoid any real sort of mishaps. All right, so linear algebra, you guys all sort of said that you had taken linear algebra before, right? So it's a pretty straightforward thing to do. It is a really important subject anymore for computer science, for any kind of computer programming. So I'll throw embedded design in there. It's really common to use it. It's a really boring subject in the sense that like all you're doing typically is like you've got a system of equations and you're trying to solve them, right? It's a boring thing. But it's a really useful way to deal with large tracts of data. And that's why it's become more and more important. If you haven't seen it, you want to review it, chapter 5 of the book has a lot of details. I'm not going to get into some of the weird things that you might have done there, like column spaces and row spaces and that kind of stuff. But basically just, hey, here's a system of equations. I need to put that into matrix form to solve that system of equations. All right, that's something you should be comfortable with. A place where you would see this. All right. I don't know if so in linear algebra at all. Sometimes in 2111 they deal with linear algebra. Sometimes they don't. It's a good thing to do it if you don't. But if I got a problem like this, let me ask. So how did I come up with those equations? I don't want to do the analysis to do that, but how did I come up with those equations? Mesh analysis, yeah, right. So I went around those 3 meshes, got those equations. Okay. I want to solve for I1, I2, and I3. Well, I can put that in matrix. Okay. So what would that look like in matrix form? If I tried to map this into a matrix form, what would I have? So a 3x3 matrix, right? And then what would be in that 3x3 matrix? What would be the top row? 10,000, 0, negative 6,000. All right, and then the next one would be 0, 12,000, negative 3,000. Yep. And the last one is what? Negative 6,000, negative 3,000, and 21,000. All right, so I'm getting late. I'm gonna write them as K, right? Now, what does that get multiplied by? It'd be multiplied by a vector. And with that, is that a column vector or a row vector it gets multiplied by? Column vector, right? What would the column vector be? No, that's not what it gets multiplied by. Yeah, this gets I1, I2, I3, and then I set it equal to a column vector, right? And that column vector would be negative 6, 6, 0. All right. So, and the way that I do this is I think 10,000 times I1. So you go along, the rows, then down the columns of the second one, and the result equals whatever's here, right? So 10,000 times I1 minus 0 times I2 minus 6,000 times I3 is equal to negative 6, right? So I should be able to recreate these equations by going down across this row, down this column, okay? All right, so how do I put that into MATLAB? Help me out here. How should I do that? So I'm gonna
That's the solution. That's all I know. That's all I remember.
okay. So you know the term RREF, right? All right. Well, so so you did MATLAB for that.
No, I didn't.
TI. Oh man. Okay. All right. Yeah. All right. I hate the TI. But it basically, I mean, there is an RREF. So okay, I do this here. Clear all. How would I enter this into MATLAB? So I got to put it in square brackets. So A is what I'm going to, I put it in this form here, right? So I was using the form AX equals B, right? So ultimately X is the unknown, right? I got A, I got B. All right, so help me. How would I set up A? A is this matrix here. What would I write? First row, yeah. So I would do 10,000, 0, negative 6,000. And then how do I get to another row? Semicolon, right? And then it'd be 0, 12,000, negative 3,000. And then it would be negative 6,000, negative 3,000, 21,000. And boom, I'm done. All right. And then B is easy. All right. How could I write B, which is this guy over here? Yeah, I could do negative 6, semicolon 6, semicolon 0. An even faster way to do it is to use what's called the transpose operator. So what's the transpose of a matrix? You swap the rows and the columns, right? Yeah, so what I can do to do that is I can write negative 6, 6, 0. So I just wrote a row vector. But if I do the tick mark, that's a transpose in MATLAB. All right. So now I've got that all set up. And if in this case, I could call it X, but I'm looking for current. So I'll say I equals the inverse of A times B. All right. And then I'll come up with my answer. So if I again, what I'll do is I'll highlight that and I'll say evaluate selection. And somewhere there's my currents. All right. So they're milliamp type currents, right? That's just to interpret what I've got here is what this is saying in my output. This is a column vector that it output, right? But it's saying I have 10 to the minus 3 times this answer, 10 to the minus 3 times this answer, 10 to the minus 3 times this answer. Yeah, it gave me my three currents. So the first one would be I1, second one would be I2, second one would be I3. So if I wanted to isolate them, I could say, well, what's I of 1? That'll be the first entry. I of 2 is the second entry. So if I want to isolate those values, I can do it that way. You guys will have an example. You got a mesh or a nodal problem, I think, on homework too, that you got to do and solve this way. All right. And usually when I teach 2112 or 2111, I just throw you right into doing this in MATLAB because you can get the equations in there fairly straightforward. And if you talk to Yao will be perfectly okay with you doing that probably. And he may do that at some point in terms of, I'm not sure how Yao is doing it these days in 2112. All right. All right, so that's a pretty straightforward concept, right? This stuff is not the most exciting stuff in the world, right? So the key thing is, if I want to check the size, I use that size command, okay? M rows, N columns, all right? If you don't know how the commands work, help or just Google, right? Help is a command in MATLAB. Say help this. If you're not sure how to do something in MATLAB, you can just go to Google and say, in MATLAB, how do I do this? The MATLAB has its own command called look for, where you can say look for, and put a topic in. It'll tell you a couple of different possible commands that might be close to what you're looking for. All right, anymore, that's not that useful because you can just use Google. But all right, so here's the way that I wrote that, so you can take a look at that later. All right. And again, a typical sort of help page, there's a lot of good, useful stuff on there if you go into those help pages. All right, so I want to talk through now some other stuff that we got to get into, which is how I manipulate arrays and things like that. So let's say I have couple of useful commands here, 1, 0s, lin space and log space. These are a couple of useful commands. 1s and 0s. Let me not talk so much about lin space and log space at the moment. Forget about those, but they're here. 1s and 0s. Those are useful. Creating a matrix of 1s or a matrix of 0s. Okay. We're going to use 0s here in a second. 0s is a really useful one because it basically creates something I might load up with values later. Okay. So we're going to use that here in a little bit. Now, one thing that you often have to do is something like this, right? So where I have two functions that multiply each other, okay? So let's say I have cosine 2 pi 30t times sine 2 pi 10t. You've got stuff like that, in the homework. And I wrote this in a mathy way here where I said, okay, I want to generate this for t that's an element between negative 0.1 and 0.1. That's a math way of saying, right, I want a continuous function that exists over that domain, right? And so if I wanted to create that vector y, right, the way that I would do that typically is the first step would be to make a time vector. Second step would be to make the cosine vector and then make the sine vector and then multiply it. Question is, how would I do that? Okay, so let's say I wanted to do that. All right, so let's say what I wanted to do is, let's see, here's how I started trying to do this, right? So I defined a t vector and I made up so it's going from negative 0.1 to 0.1 and the steps are 0.1 divided by 10,000. Okay, that's just what I decided to use. There's x1 and there's x2. So how should I create this y that I'm talking about? How should I do that? Should I multiply them? What's going to happen when I multiply them? So let's run this guy here. Let's execute that. Let me go to my command window. So x1 and x2 are the two vectors I just made. So let's say I do y equals x1 times x2. What do you think is going to happen? I get an error, incorrect dimensions, because MATLAB's meant to deal with matrices. So what did I do? So what were the sizes of those two vectors? So let's make sure. So the way I define t here, what is t? What kind of vector is t? A row vector or a column vector? Row vector. So what's cosine? What's this x1? It's a row vector, right? x2 is a row vector. So I just tried to multiply two row vectors, right? So in linear algebra, if I took a row vector and multiplied it by another row vector, can you do that? No, you can't. So what should I do instead? Transpose one. All right, so let's try to do x1 times x2. Now, let me ask you this. How many entries should exist in the x1 times x2? the same as each other, right? So let's just do a quick check, right? So size T has a size of 20,001 points. So what should be the size of X1? 20,001. And so it's saying one row and 20,001 columns, right? And X2 would be the same thing. So now let's do X1 transpose times X2. Now, who knows already what's the size of that going to be before I even do it?
Like a combination. Oh, it says there it is.
It's going to be big. Yeah. It's going to be, if I said, what's the size of that? And if you go into your linear algebra, I think it's going to be 20,001 by 20,001, right? So, okay, well, that was the wrong way to do it, right? So what should I do instead? Should I do this? What's that going to be? It's going to make one value, one number, right? So, turns out there's no real way to do that, right? So, but it's common to want to do it. So MATLAB has a function called element-wise operations. In other words, I want to multiply each element in one vector by every element in another and create an entry for that multiplication. So if you do that, you use a dot multiply, right? Or a dot divide if you were trying to do that, right? So x1 times x2 would be the way that I would do that. So y equals x1 times x2. This is where it's useful for me to put a semicolon so I don't have to watch everything go by, right? It comes out pretty quick. And I say, what's the size of y? Same as the size of x1, x2, and t. Okay. So that's called element-wise operations. And if I wanted to do something like take every entry in x1 and square it, I would do that. All right. And the size of that's 20,001 points. Okay. So that's a pretty common way to play with this. Now that's to say, defining something like this could all be done in one step, or you could break it down into multiple steps like I have here. All right, in my thought process. So notice I put a couple of examples of what I just did here into my notes. One thing that you sometimes a command that I use is this more on command. All right, what it does is basically, so instead of just scrolling all of data past you until it's finished, more on lets you see the data as it comes along and is created. Okay. If I do more off, it goes back to the regular mode. Okay. So this element-wise operation is really important. All right, so you're going to need to use in the next homework, not the homework due today, but homework 2. You need to do looping. MATLAB's got the ability to do for looping and while looping. That would for looping and while looping. In problem 1 of the homework, I ask you to basically do the same calculations that I just did, this element-wise stuff. I ask you to do that also using a for loop and a while loop. All right. And it's not hard at all to do it, right? If you review these pages in the text, right, 146 to 149, they'll address how you do looping, right? I'm not going to talk through that. You know what a for loop is, and you know what a while loop is. One thing that I have not said yet, which I should say, I should have said this earlier. In C, what's the first entry of an array? What's its index? 0. In MATLAB, it's not. MATLAB, it's 1. All right, that's going to mess you up. All right, to me, it makes more sense that it's 1, right? Because counting starts at I have one thing, and that's at the first location. So I don't know. To me, it seems more natural, but that's something that may cause some of you some issues. Will cause a lot of you issues probably because you're so used to thinking of 0 as the first entry. All right, let's say I want to. So you're gonna have a couple of problems like this in homework 2. Where I have a graph here that I graphed this function. All right, x of t is a piecewise function. It's 3t squared from 0 to 0.5, and then it's 0.75 for everything after that. Let's say I wanted to make that graph. Okay, where would I start? What would be the first thing you would do to make that graph? Well, first thing I'd do is make time vectors, right? And I don't even need to make 2 time vectors. I could just make 1. And well, I always tell you what the increment's going to be. Where would you start the time vector and where would you end it? So it looks like I went from 0 to 1. So I start at 0. And I don't know what value I used here in my example. What value did I use? 0.01. All right, I'm going to do steps of 0.01 all the way up to 1. Okay, that's step 1. Make a time vector. Now, how would I create these two guys? Think of this in terms of looping. How could I write a loop that might fill up an x vector? And I say looping is a general concept, right? You've never written a for loop in MATLAB probably, but you know what a for loop is, right? So how would you think about just looping this to create it? I could, yeah, right. I could just continuously plot it. So what I would do is I could write a piece of code here where I create my t vector, right? So t goes from 0 to 0.01 all the way up to steps of 1. I'm going to put everything into an x vector, right? That's going to be my output. Okay. So I need, like any, function, I got to initialize my variable here, right? So how could I create x? Well, a good way to create x, which is going to store my output, would be to create a vector of zeros, right? So what did I say you could do with that? I said, well, there's a command called zeros, right? Where I can say, I want to create a vector of zeros. Now, how big should that vector of zeros be? Size of t, right? The exact same size as t, right? Which I could figure out what that is, right? Now I got to fill up that vector. So I can do a for loop. All right. Now, in MATLAB and again, I point you to this 146 to 149 to get all that stuff. But in MATLAB, your loops start with whatever the keyword is, and they always end with end. Okay. Now, in this case, what am I going to do? How do I figure out how to loop this? Well, I've got 2 sections. So for my 2 sections, I'm going to need an if statement probably, right? To figure out whether I'm in this section or whether I'm in this section. What would my if statement be looking for? Yeah, if the t is less than or equal to 0.05, and then greater than 0.5. Okay. So for that, basically, so how would I go through the for loop? Now, what I would end up doing is I would basically say, I want to loop through, like in C, usually say, okay, for I equal, for I from 0 to some number, right? In certain steps. So MATLAB, you'd say for I equal to 1 in steps of 1 all the way up to wherever I want to stop. So how many times do you think I need to go through this process? Well, yeah, so all the way up to the size of t. So if I looked at the size of my t vector here, so I said there were two useful commands, size and length, right? So if I know we're running up on time, so let me just get through this here. All right, so let me run this. All right, so I just created that t vector. So if I type size of t, I get 2 numbers, 1 and 101. So I can't put size of t here because it's 2 numbers, right? I got to get 1 number. Which number is it that I want to get out of there? The 101. So the other command that exists is length. So I can say length of t, and that outputs that number. Okay, so I have this guy going 1 to 1, and I would write length of t. Some of you will end up writing 101, right? That's okay. You could do it that way, but I don't like hard coding it. Now, and here is the code I have to write to fill that thing up. Okay. Now, we don't have enough time to do that. That's, you guys, I have a video I'll post on the if statement that shows you how to run through that one. Okay. But this, you've got some stuff like this that you're going to be just playing around with in this next assignment. Okay.